Dear friends, in today's class, we are going to discuss first of all what is the difference between the sequential access file and a random access file. Then we have to discuss random access file functions with a suitable example. What is the difference between the sequential access file and a random access file? Remember, till now, whatever the file function we discuss, get C, put C, get W, put W, fread, fwrite, fscanf, fprintf, all are the example of sequential access file function. But in random access file function, we have to discuss three important functions. One is ftel, one is rewind, one is fseek. What is its purpose? We have to discuss. Before discussing that, let us clarify what is the basic difference between the sequential access file and a random access file. The answer is, when you are reading a cassette, then you have to read the songs or the data one after another without leaving first record. You cannot move to the second record. Means we have to move sequentially. But what is the random access file function? For example, while you are reading the CD or while you are writing the CD or a DVD, or you are reading writing into the hard disk, or simply is the random access memory. Suppose data is in one number record, randomly we move to the 100 number of record to access directly. And hence random access file function is faster in comparison to sequential access file function in comparison to all aspects: reading the data, writing the data, while changing the data, updating the data, deleting the data, and hence access process become faster in comparison to sequential access. Hence we have two types of access methods: one is a sequential access and one is a random access. Now it is clarified in detail. Sequential access to a data file means that the computer system read or write the information sequentially, starting from the beginning of the file and proceeding step by step. On the other hand, random access to a file means that the computer system can read or write the information anywhere in the data file, means not sequentially. By skipping something, we move to the directly to the other location. Just like suppose in a queue, the people are standing, 10 people are standing, so that I can serve 1, 2, 3. Without serving 1, I cannot move to the 2. That is sequential. Suppose 10 people are standing in a queue. I am first moving to the 1, then randomly moves to the 5, then randomly moves to the 10. That is the concept of a random access. Sequential access means without skipping one step, we cannot go to the next step. But in the random access, by skipping one, we can move directly to the other location. That is known as your random mechanism. The example of sequential access is, as I told, the ribbons, step ribbons previously were used in cassette system. That is your sequential access. But accessing the data or read-write process of the data in RAM is the example of what? The random access. That is written. A common example of sequential access is with a tape drive, where the drive must move the tape's ribbon forward or backward to reach to the desired information one after another. But opposite is into the sequential access is random access memory, that we can go anywhere from one location of the chip to the another location. The example of sequential access file function include, as I have told, get C, put C. The example of random access file function include ftel, rewind, fseek, and others. Let's first discuss what are the concept of the different functions like fseek, ftel, rewind. Then we have to go by the example. What is the work of fseek function? The work of fseek function is to move to a position in the file and access the data, and the position may be the start, end, or at any location, which represents 0 means beginning of the file, 1 means the current position, 2 means the end of the file. And hence fseek function's syntax is file pointer, displacement, pointer, position. File pointer means on from which file you want to read the data. Displacement means how much byte you want to extract from current position, either in forward direction or backward direction. Means why the L is given. Suppose 2L means 2 long integer, 2000L means the long integer, L for long integer, minus 2L means from current position to the backward direction. Only suppose 100L means 100 byte you want to extract current position to the forward direction, means right position. Suppose there is 10 character, we are in the 8th position, suppose 2 means from 8 to onwards, minus 2 means from 8 to backwards. Hence, two types of value can be given in the displacement, either in the positive or in the negative. L represents the long integer. 2, 3, 4, whatever you want to write, that is known as that much bytes of character you want to extract from the file. Hence, file pointer represents the pointer where the file locates. Displacement means it is a positive or negative. This is the number of bytes you want to skip backward, if negative, forward if it is positive from the current position. This is attached to L. This is long integer, because if 1 lakh of a character you want to access, then you have to write 1 lakh L. Pointer position means 0 is the beginning of the file, 1 is the current position, 2 is the end of the file. How you have to write? Suppose you write fseek_p is the file pointer, 10L means 10 bytes you want to extract in positive, means forward direction, 0 means the beginning of the file. If 1, that is from current position. If is the end of the file, there is no positive, that is negative value, negative L will be given. Why negative L will be given? Because at the end there is no forward direction, there will be backward direction. And hence fseek carries 3 arguments. One is file pointer, one is displacement, means how much byte you want to extract, and pointer position means where your file pointer is, either beginning or end or at the current position. Then what is the work of fseek function? As 0 represent what, 1 represent what, I have told you. Again, it is represented in detail. 0 means the pointer position is the beginning of the file from where 10 bytes of data will be extracted in positive direction, because 10L as positive. If it is written fseek p5L 1, 1 means what? As I have previously told, the current position. From the current position, suppose in a 5 number of character position we are there, 5L means from there rightwards 5 bytes. Suppose we are at the end of the file is represented as 2, then there will be minus. Why? Because there is no end of the file, there is no forward direction. Hence, from there in the backward direction we want to access the file. Instead of that is 1, that should be written as 2, because 0 is for beginning of the file, 1 is for the current position, 2 is representing the end of the file. While the 2 is given, the backward direction will be given. Or suppose 10 character will be there, suppose you are in the 5 number of character, there can be also backward direction, means from the 5, 4, 3 to this direction data can be accessed. What is the work of ftel function? Where your file pointer is there in the current position, ftel will represent. Suppose in the beginning the first character is 0, then the next character is 1, means current file pointer position will be written by ftel function. What is the work of a rewind function? Rewind function's work is where the file pointer will be there, the cursor will move to the beginning of the file. Suppose in the 10 character the file pointer position is there. If we give rewind, it is returned to the beginning of the file. fseek extract the specified number of bytes from the file. ftel return the current position in the file. Rewind returns where the file pointer will be there, the cursor moves to the file pointer moves to the beginning of the file. And hence ftel, rewind, fseek randomly moves from one position to another position. Hence they are known as your random access file functions. Let's take the example. Suppose you have taken file pointer, character variable you have taken, the file, suppose where you want to read, that file must be existing. So let that file is file1.c, where the data will be read, and hence R is the read mode of the file. If the file is not present, file cannot open, it will display. If present, then we want to extract the number of character. N will be asked how many bytes you want to extract. fseek is file pointer, minus n means from current position in backward direction you want to access. 2 means at the end of the file, because I have told if end of the file, the minus value will be given. If the current position is 1, then the minus n or plus n will be given. Because in current position, if there is rightmost character is being there, then the plus can be given. If the before character you want to extract, the minus will be given. If it is 0, from there the beginning of the character, the rest of the character in forward direction will be accessed. Here fseek minus n means from the end, backward direction the data will be extracted. If it is 0, from the beginning. If it is 1, is the current position. If it is 2, from the end of the file. Now, till when we read? Till end of the file. The getC and fgetC is same in a random access file. Instead of getC, we write fgetC to read one character. Suppose we read a character, test, it is end of file, no. It will display that data and its position will be displayed. Whatever the position may be 0, the position may be 1, the position may be 2, anything else. Suppose from the beginning of the file, the first character is suppose A, the first position is 0. The second character is B, the second position is 1. Accordingly, how many characters will extract, that position will be displayed. If it is end of the file, then it will come out of the loop, and till then the result will be displayed, and output depends upon the content of the file. Content means how much data will be written, accordingly that character will be extracted and that position will be displayed to the user. Let comes to your editor. I have written previously. Open that file as rand.c. Let's see what is the name of the file, and accordingly we will open. Just wait. What the name I have given previously? The name of the file I have given, that is rad.c. Let open that file. rad.c. Before reading that file, let's see which file you are reading, that is o.txt. Suppose I move to the DOS cell, type o.txt, or you can move to your Turbo C editor. In the bin this file will exist, because I have told there must be a file to exist. The data is written as rew33. From there we want to read the data, means the character will be extracted and the position will be displayed. Suppose how many data you want to extract? Suppose 5. Then what it will display? It will display its a positional character. Suppose I want to extract, that is 2, then the value W, its a position, space its a position, 3 its a position, 3 its a position. Suppose I want to extract 3, then the rest of the character will display. Suppose I want to display 1, means 1 position it will get, and display its position, means each character will be extracted with its position number will be visualized. In this way, we discuss the functions related to the random access files, and I think you understand these sessions. Having any doubt in random access file function, please make the comments. Having any remark, please give the remark. You like the video, kindly like the video. If you did not subscribe, kindly subscribe the channel. I think this session is essential to you. We will be coming with some new problem related to the file handling, as it is a big chapter. In the next class, we are going to discuss a new important thing, that is command line argument in C, so far as the file handling is concerned. Thank you. See you in the next class.